Hey guys, almost ready for a power-up test. Got the output transformer patched back together. I'll try that secondary bypass trick. Keep your fingers crossed. I've got all the bakelite blocks rebuilt, except for this guy. Got the new filter caps wired in, the AC motor run caps. While doing so, working in this area, I noticed there's a bit of corrosion on the chassis, and you can see there's some crud here. I think that's from the old capacitors leaking out. Also, clearly there had been some, I guess, old repair attempts on this. For example, this right here is the main B+ filter choke. And this lug had been clipped, and this power resistor had been routed to the input side of the filter choke rather than the output side. Be a little bit higher B+ here, but it won't be filtered as well. I routed this new resistor as shown on the schematic, and there are a few other little parts clipped here and there and things not wired up quite how the schematic showed. Well, I put everything back the way I believe it should be. And what I wanted to show you now is how I am rebuilding these bakelite blocks. Lots of different techniques. I'll go over a few of them. One is to leave everything connected, take out the screw, clip the little bit of internal component leads coming through here, flip it around, dig it out, or drive something like a wood screw into the block and pull it out, put in the new part, flip it back around, solder the new leads in. I've tried doing that, I've had some success, but often I find there's not enough room, the wires are too brittle, and the insulation starts flicking off, components are in the way, just too crowded. So I like to completely remove the block. Once I do, I'll show you how I go about replacing the insides. And here it is. Now this one is also a little odd in that you'll see on the parts list referred to as number 37, I have two condensers marked, a .00011 and a .015. Well, in reality what that is it's this external mica cap that was threaded through on one end, and that would be the ground end, and the other was soldered onto here. Now you may notice these caps in Philco sets. Bakelite, square, rectangle, and a yellow blue dot. It's 110 picofarad. They came up with their own color scheme. Again, I think it was to aid the assembly line workers to clearly identify components. I've had pretty good luck with these being good, so I think I'll be reusing that. And then what remains in here is the .015. Notice the center lug doesn't have anything coming up through this hole, and these two do. That is the internal component. Just going to cut these. And then we want to get this out. So basically two techniques, heat and cold. I used to use heat. With a heat gun, heat this up, it'll soften. Seems like tar. I've seen Philco refer to as high temperature wax. It sure seems like tar to me. One inside this tar blob is a paper wax jelly roll capacitor. Cold, some guys put these in the freezer. The colder you make this, the more brittle it is. Well, it being winter, almost spring, it's still kind of cool weather-wise. And I find this, not that I don't have the heat on, but it's a little cooler than it would be in the summer in here. I'm finding it pretty easy to chip out. So I'm using a small flat-bladed screwdriver and dig it out. And you want to be careful when you do this, don't dig down and pry over, especially on the end here, because you would just crack this thing right open. And all these bits of stuff that come out try to be kind of neat. You don't want to get these on the floor and step on them because they will spread out and mush and stick to the bottoms of your shoes and spread out over the floor. Kind of a pain to clean up. So if you heat this up, it certainly gets softer, but it also gets kind of smelly. So when it gets a little bit warmer, it gets softer, and if you get it warm enough, it'll actually flow. And just start to see the capacitor emerging here. So the size of whatever you find in here is pretty well directly related to its value, and capacitance, and its voltage rating. The higher the capacitance, higher the voltage rating, the bigger the component's going to be. So this one's fairly large. It goes pretty much from one end to the other. So I could just plunge this down right now and try prying up this end, but I'm afraid of breaking out the block, so I'll go from the other end, and here it comes out. So that's it. That is the capacitor. Sort of like wax paper and then metal foil. And that is what goes bad. Past effort, it's because of moisture, but recently I've been referred to some studies that were actually done back in the day, and it showed that it was more from acid and the paper breaking it down, just like in old books. You may have heard of acid-free paper that artists like to use because it won't turn brown or deteriorate over time. I mean, for sure, moisture is an issue, which is why they have this encased in the first place. Apparently, they had a problem with the paper just breaking down over time. That sounds pretty well cleaned out. Remains of the old lead out of there. So here's one of the ends that was coming up through that hole on that side. I do not encapsulate the new components. Don't see any reason to. I mean, they're encapsulated on their own. You know, with modern plastic. Nobody can see them underneath the chassis, so why bother? Alright, so we'll double check that. Oh, something else confusing. So on the parts list they show it as dual capacitor, but they have two separate part numbers. When you look on the schematic, there's two capacitors, both identified as 37. So it's this guy here and his guy here. And you'll see that several places on here, or they go, for example, here is a 33 and a 33A. Or for this 40 filter condenser, I think they just label it as 40 throughout the schematic. It's rather annoying, like here, 42 microfarad, 40, well, at least I put a B next to it. I guess that's the C section. So yeah, Philco was not the greatest at identifying the parts. I don't know if it was because of revision changes or whatnot. Alright, so now we need a new capacitor. These guys. Doesn't really matter. Use the yellow, use the whites, use the browns. Different manufacturers, different case styles. I like using these. Radial type. Inexpensive, good name brand, Nichikan, rated for 630 volts, far exceeding the specs. And when you bend the leads a little bit, it fits very nicely inside. So check the spacing here. Go a little bit closer on those. And you simply put the leads through the holes. Clean this one out a little bit. Wrap them around those little lugs and then reinstall and hook the wires back up. I took some reference photos. Find that very helpful. Knock this one out a little bit. Sometimes this tar stuff can melt a bit and clog up the holes. There we go. And wrap it around these lugs. I'm going to heat it up a little bit and kind of go around the tip, and I can get the remains of the little leads off. Let it flick, get some of the solder off. Alright. And those pliers. Solder those up, trim off the access to and reinstall it, and that is that. That is how I rebuild these. The center lug is just uses the tie point, no component connected to it internally. Just about ready for a power-up. Now, rather than restuffing this electrolytic, I just put in 3 discrete capacitors. Here, here, and here. These values are so small, it just didn't seem worth the effort. It's 1 microfarad, 1 microfarad, and 2 microfarad. Well, modern film caps are so small now, that's what I use. So 450 volt, 1, and a 2.2. That just leaves one more left to do, which is this 10 microfarad down here. And then I need to wire up this output transformer. I remounted it, but I haven't wired the leads back in yet. So I'm going to try that trick of bypassing the primary and driving the secondary directly. Hopefully that will do the trick.